So 3.1. So the quiz is 3.1 and 3.2. 3.1 was critical numbers. So that's f prime equals 0 or f prime undefined. And again, you can take notes on this or just watch and make sure it makes sense to you, whatever seems best to you. And then we use critical numbers. Oh, you know what? Let's draw the little roadmap again. Critical numbers lead to possible extrema. And then we've done two things with this. We found absolute extrema. And we found relative extrema. Now, what did we use to find absolute extrema? How did we take this top route? Table of values. And then you just pick off the highest y value is the max, the lowest y value is the min. That path was 3.1, so that's on the quiz.
For the table of values, are you substituting the x values into F1 or normal F?
Into F, that's a good question. Table of values where your x's are your critical numbers and endpoints.
They'll give us endpoints, right?
And they will tell you, find the absolute minimum between, -1 and 7 or whatever. So they will give you the endpoints. And then yes, you're looking at F because you're trying to just see who's the highest and who's the lowest. How do we find relative extrema? First derivative test. That's not on the quiz, but just to sort of finish the picture there. That part's not on the quiz. So we know how to do it, but we're not asking for that.
First derivative test is the thing with the number line, right?
Correct. Number line, increasing, decreasing intervals, f prime changes, positive to negative, all that stuff. That's 3.1. 3.2 is roles and MVT. Roles has 3 conditions. What are those conditions? Continuous, differentiable. What's the difference between those two? Because they're really close, but they're not exactly.
They're both the same, like the ends are the same, right?
That's step 3. But what about, let's finish the thought on step 1 and 2.
Continuous one like this, like square brackets.
Continuous on the square brackets.
And then differentiable on like the curve.
Yeah. So continuous at the endpoints, differentiable doesn't have to be at the endpoints. Sometimes there's a cusp at the endpoint, basically, and that's okay. Because it doesn't have to be differentiable at the endpoint, just right up to the endpoint. And then the last thing was, like you guys said, the y value at the endpoints have to equal each other.
It's just not differentiable if it's if the slope is undefined, or
If the slope is undefined, or if the slope is, vertical tangent line would be undefined as well. So a cusp. What function have we looked at that has a cusp? Absolute value. So you got to be careful with absolute value because it's somewhere not differentiable, but is the somewhere a point of concern or not?
If you get a question that tells you to do like MVT or rules and it is like not differentiable, you can just say no.
Yep. Yeah. So the question was, if we get a question that asks us to do roles or MVT and it doesn't fit the criteria, then you say it's not differentiable at x equals 7 or whatever, and therefore roles doesn't apply. Done. I will check again, but I'm pretty sure there's 2 roles questions on the test. One works, one doesn't. Quiz, sorry. What's the conclusion for roles? Then, yep, so that means the slope somewhere equals 0, and your job is usually to find C. So you set the derivative equal to 0, and you have to get an answer if all of this stuff works. So you know there's at least one answer. In VT, all you need is continuous and differentiable. But the then is a little bit more confusing. Not confusing, complicated. Say it. Calculus slope equals algebra slope. Now that's true. That's probably not enough to, to finish the problem. So what's sort of the symbolic way to say calculus slope? What's the formula, or what do I write next? F prime. Where? At C. That's where we don't know what we're looking for. Equals algebra slope. That's y2 minus y1 over x2 minus x1, rise over run, any of those slope formulas that you know. So you find this, take a derivative, set f prime equal to whatever slope you got, and you should get a c that's on that interval, at least one. So